In this first case study, a fire not caused by the PV system, but did result in a damaged and hazardous PV system. This was a residential structure that experienced a nighttime garage fire with extension to the upper floors. You can clearly see there was extensive heat damage to the garage and the cars in the driveway. Here, firefighters are covering the array at night to protect them from shorting when the sun comes up. As we get a view of the Bravo side, we see some electrical equipment. The drooping conduit we see here is actually the AC line coming from the inverter on the other side of the fence to the left. We can see the AC disconnect is in the off position, so there is no voltage in that line. We'd expect to also see the main breaker off as well. But if only the AC disconnect was off, we would know that the inverter is also off. So that line is definitely dead. But what about the DC line coming down off the roof? Is it damaged? And as you can see from this angle, the PVC conduit is damaged and the wires inside are exposed. When illuminated with scene lights or by the sun coming up the next day, these wires could begin to arc and are definitely to be considered a shock and fire hazard. Clearly, this can happen anywhere conduit is damaged, inside an attic, ceiling, or wall. So you can see the value of being able to reduce the voltage within the PV system in an emergency. In this case study of a fire caused by the PV system, we see a very large commercial distribution warehouse with a PV system on fire. There are only about 4 modules and a combiner box involved. And the fire department made an aggressive offensive attack and safely deployed a line to extinguish the fire. The post-fire pics show the area of damage and the minimal roofing damage due to the fast knockdown. What we also see is a large raceway containing large diameter wires called feeder conductors. These are the big wires that come out of a combiner box, where maybe 15 to 30 separate strings come in and then transition to one large positive and one large negative wire. The scary thing here is that these wires are exposed and are likely still conducting close to 500 volts and several hundred amps. There are no disconnects at the combiners on this roof. The code requires them now, but in this older system, it's now in a very dangerous condition. Knock the fire down from a safe distance and then stay clear of all metal components. This incident began as a dispatch for an attic fire. Arriving crews found a daytime fire contained to an attic of a single-story home. Aggressive firefighting again contained the fire to the attic of the room of origin. There was also a PV system on the roof, but the crews were unaware that the PV system had a bad connection underneath the array, which overheated and created an arc that actually burned down through the roofing, starting the attic fire. Suppression would be no different, but crews should identify potential damage to the PV system and ensure that the system installer respond to secure the system on the roof. Here we have another residential system that experienced a fault resulting in a fire within the array. Crews did a great job identifying the presence of the PV system on the command channel and extinguished the fire from an aerial ladder. Overhaul should be avoided as contact with energized conductors may occur. The common theme here is to avoid contact with a damaged system. Even with the safety of a system with module level control, care should be exercised when dealing with a damaged system. PV modules perform best in cold, sunny conditions. The hotter it gets outside, their efficiency drops, but they operate fine. Shading, however, can be a problem when strings of modules are producing different voltages. In this case, the string of modules was installed in a location that was shaded at the middle of the day, the highest voltage times. This system caught fire due to a failed bypass diode, which caused the module itself to overheat. The firefighters exposed the sheetrock in the structure to check for extension, but there was none. But the images of the damaged modules on the lawn highlight that the awareness of the potential for lethal levels of voltage and the need for training of firefighters was apparent. Occasionally, for various reasons, we're unable to perform the level of overhaul we would like to. When there is a damaged PV array, the best course of action is to apply water from a safe distance and ensure that a trained and qualified individual with electrical PPE respond to remove the damaged modules and secure the system.